Thank you very much, Monique. This was really great. So before I move to, we have already many questions here. So I'll give people a chance to reflect on everything you said and to get warmed up for questions. So we'll start with some questions. So the first one, which it's kind of a tradition, I would like to know, I understand you have a mathematics background. So how did you get interested in conceptual modeling? What was your particular way into conceptual modeling? And before, because I suspect my second question is going to be intertwined with the first one. So you were working on this on, let's say, the second half of the 90s, right? So this was a time in which people were proposing many different object-oriented methodologies, right? So I think that the Merode IEEE transactions paper is from 98, if I'm not mistaken, right? So this was just after UML, the first version had been proposed. And you put together a number of things which were not very traditional in conceptual modeling. And I mean this in a really possible way. I thought it was highly original. You're taking existential dependence. You know, clearly you explicitly talked about your influence coming from Michael Jackson and from Tony Hoare's process algebra. I think object event tables comes from James Martin, if I'm not mistaken, right? So you were putting together a number of very interesting things, and thinking about process algebras in this context, it was quite original. I mean, they were very used in protocol engineering, for example, but not so much in object-oriented modeling. So that's my question. I mean, how did you come up with this idea of putting these things together, and how you as a mathematician got interested in conceptual modeling?
Well, I studied computer science, and then by accident, because I am like the perfect example of non-career planning, I started working in a bank. And in the bank, it's one of the largest banks of Belgium, I became responsible for methodologies and tools. So I was responsible for training the business analysts and looking at the methodology they would use and the tools they would use. And there was this very big project where we were looking for a new tooling for the bank. And there were several important things happening. IBM at that moment was, for example, trying to make a repository that would interface to all possible tools so that we could share and exchange models. So that was some big issue at that moment. There were 4 generation languages coming up. And there were also a few code generation platforms coming up, like, for example, Telon. And James Martin was also very famous at that moment, and Telon was one of the tools that was borrowing on James Martin's methodology. So through the 2 years that I worked there, I became very familiar with all the tooling. And of course, I was visiting all these vendors in an attempt to make a comparison. And every time I was thinking, there should be a way to make this smarter. There should be a way to make this smarter. It's too stupid. We should make this smarter. And then, yeah, I must say I was in those days, my boss was a kind of very blunt, saying that because I was a woman, I couldn't get a promotion. So I left the bank for that reason. And that's how I ended up at university, where my promoter, Guido de Dene, I knew him. He said, yeah, come and work with us. Come and work with us. I said, okay. Mm-hmm. And that's how I ended up at university. And there, in the group of lyrics, there was already quite some research on entity relationship modeling and Jackson systems development. So my predecessor was a big fan of Michael Jackson. And one of the previous PhD students did a research where he proposed that a good modeling approach would be to have an entity relationship diagram and to define for every entity a Jackson diagram. So you will see, if you look at the old Merode book, you will see that the basic idea was entities and Jackson diagrams. But then Guido de Dene being also a mathematician, and me too, and both interested in algebra, this notion of marsupial entities for us was kind of evident that this was a lattice structure in mathematics. I had also a good training in compiler theory. I bumped onto a paper where CSP was used to formalize Jackson diagrams, and then yeah, you add 1 + 1 + 1, and you just, it, for me it was like all the pieces of the puzzle just like plopped together, and it became like almost self-evident to do it this way because it was fitting so nicely.
Very nice. I must say, you know, their loss, the bank, our gain. That you can.
Yeah.
To do research,
and of course, because of UML, I got rid of the Jackson diagrams and I replaced that by state machines, because a Jackson diagram is nothing else than a regular expression, and a regular expression is a language generated by a finite state machine. So, like I said, it all fits together.
Mm-hmm.
Yeah.
Yes, yes, it makes perfect sense. So I'll ask a final question then before I move to the questions from the audience. So I really like this idea of the process playground. This is basically the idea of what I was talking to Oscar Pastor last week about Mario Bunge and this idea of a lawful state space, right? So you have all the possible states in which objects can be.
Yeah.
And so this seems to really, I really like this idea of thinking of a process as constraints over this lawful state space, right?
Yes, that's it.
And events there as well in Bunge's approach. Events, as Oscar mentioned last week, they are basically transitions, right? So they are pairs of states, so transitions between states. However, you know, again, from an ontological point of view, it makes perfect sense to take events as first-class citizens, right? And we sometimes want to represent in what is called the data model, so the structural model. We want to represent events with their properties, with their taxonomies, and so on. So, although most people working on this viewpoint consistency between behavior and structure focus on events as changes to the objects. But I would like to know your position on this, because what you did in one of the diagrams, you were exemplifying events, right, for which people can acquire tickets and so on. So these events in the models are entities, but they are not connected to these entities which can change in the other model.
No.
So can you elaborate on this? I'm very interested in this problem.
Yes. When I started chapter 5 in the book, the first thing I do is I explain that you can have the notion of event has many different meanings. So indeed, when you can consider it as something with a duration, like if I have a festival, we call it an event, but it has a duration. It starts on one day, and then it takes Balaton sound takes, for example, 5 days. So, and then at a certain moment it stops. But also you have the other notions of events as something that has happened in the past. So we are very proud that one of our Belgian tennis players won from Venus Williams. So we can say Kim Clijsters won on that day from Venus Williams. We can also, as you say, keep data about an event. For example, if I pay something in a shop, I can consider that as an event because it happens instantaneously, but at the same time, I want a trace of that. I want to know that on that day in that shop, I paid that amount of money from that account with that card. Okay? And I think all these concepts are related to each other. For me, the notion of event as a festival, I don't call that an event. Well, I know in common words we call it an event, but for me that's really like a business object. In Merode, the notion of event is actually boils down to this shared phenomenon. So it's actually, it expresses the fact that there is something instantaneous that happens in the real world, and we want to share it in the machine, with the machine. So it's a request to register that something has happened. And the extent to which you do that depends also a bit on, and there we are more in the information system world than in the real world, say. I explain to my students, we had here also in the presentation 2 models of the web shop or order management. I say you can say pay. You can model that purely as an event because you want to keep your model simple, and then you say my order, there's an event that will cause a transition from unpaid to paid, and that's it. And I don't need to know more. But it could be, of course, that payment is not that easy, and that it's like a payment coming in and I need to do a matching with invoices and so on. And then my payment becomes an object. And when the payment comes in, I have the register payment, incoming payment, and then I will validate that payment, etc., etc. So it depends also a little bit as how extensive do you want your model to be. When you need to calculate something, you can use a simple calculator, you can use a scientific calculator, you can take your computer. So you have cheap instruments and you have expensive instruments. And for me, that's a bit the job of the business analyst to decide on how to approach the problem.
I see. Thank you. So I'll move to the questions from the audience now.
Okay.
So I really like the theory that data process model, that the data process model asymmetry is a natural outcome of the layered architecture to software architecture, the layered approach to software architecture. Intuitively, this seems like an excellent explanation. Are there possibly other reasons too? For example, some static constraints are easier to evaluate than some dynamic constraints. Could the difference in complexity also have fed the asymmetry? And then there is another follow-up on that in which someone says that this asymmetry is not only software, so the data always predates software.
Yeah. I think to a certain extent, I agree definitely with the second one. I think the idea, and that's also something I discuss with my students, is when you think of the layers and you think of software design principles, I talk to them about an onion, and I say the stable things are something you put in the kernel layer. And the varying things are things that you put in the outer layer. So typically, for example, when you have an app and you want the user interface to change, that's a skin. So you can rip off the skin and replace it by another skin, but all the functionality remains the same. And I think if you look at a conceptual data model from the perspective of structure and data, the data tends to remain quite stable. I mean, my bank has been about customer accounts, and I mean that for years. I still have a physical booklet of my savings account. It's an account with a balance, and it's owned by me. That didn't change, but the processes, the way we can deposit money, retrieve money, etc., that changes a lot. So that is the reason for me that business processes are in the outer layer and that the data is in the inner layer. And then for reasons of maintainability, of course, the inner layer should never be aware of the outer layer, because then you can rip off the outer layer, put a new outer layer, and the inner layer remains unchanged. So that's the reason why the data layer is at the kernel and the business process layer is at the outside. But indeed, you cannot do anything with a data object if data doesn't exist first. I mean, you must have the object of a customer before you can start talking about registering customers, sending marketing mails to your customers and whatever. So indeed, the data predates the process. I agree with that.
So in the Merode approach, we employ state machines to handle entities' life cycles. However, business process models seem to be more interesting to provide global views on multiple processes at once and their constraints. Is there some work in the sense of developing BPM models alongside Merode ones? I guess you have this idea that the question has to do with this idea that behavior is modeled in Merode by object event tables plus
yes,
plus state machines, but you don't have a global view of temporal ordering of activities, right? So
yeah. So there is the work of here in the papers, let me see, Rafhazen. So it's the third bullet here. Existence dependency-based domain modeling for improving stateless process and action. That's already quite old work, but it's one of my PhD students from then that indeed was reflecting on, can we model the processes or capture, say, stateless processes by just using the states as they are defined in Merode. Later on, another PhD student, I didn't put his papers here, he did also research on this compatibility checking, so how to check compatibility between the two. But actually, it's not that easy. So it's really a complex problem. Mm-hmm. Because you quickly bump into problems of intractability or NP completeness for calculations and that sort of things. Because this unbounded interleaving is not finite state machine anymore. You need push down automata there. And then if you want to do calculations, you bump into the fact that it's impossible to calculate those things. So it's really not an easy problem. It would be really nice if we could do that, but it's not an easy problem. So definitely a field for research and for enthusiastic PhD students.
Very good. Could you say that a data model provides us with constraints on how a process can or should be executed? Just as a physical product may dictate a certain order in which it should be built, thus putting constraints on the process, constraints in the data model put such constraints on the process.
So what a constraint on the data model dictates the process model, yes, for sure. So I think that the data model and the way you define it, like I said, defines the playground. So it defines what you can do and what you cannot do. And when you have an eye for that, you bump into that constantly. So I just have an example. We hired new professors for us, for our group, and they have to start next year. And adding them as a teacher to a course requires them to have a teaching assignment, and in order to have a teaching assignment, you must be registered as a professor. But because they only start on the 1st of October, we will only be able to assign them after the 1st of October. No problem, academic year starts already end of September. So I'm like, yeah, you put a number of constraints in the data model, like mandatory relationships, and we have a problem. And so, yes, I see those things constantly. So constantly when we try to do things in the information system, we see that there are constraints there. And these always are data constraints, always. A mandatory attribute, mandatory relationship, and so on and so on. And then I want to do my task and the computer says, no, sorry, you need this or that information. And so, yeah, we're blocked.
So it is really fundamental that we have conceptual modeling and information systems methodology that guarantee this viewpoint consistency, right?
Absolutely, absolutely. And more importantly, and I think that's what is difficult, is that when we have a modeler, they can envision the consequences this has for the work organization. And they can really, I mean, the way you can approach it, because it's not easy, you know, you have to put constraints somewhere, but either you make a data model where you put a lot of constraints and a lot of mandatory relationships and strong existence dependencies with long chains and so on, and then you narrow down your playground. It means that the data quality will be okay, because every time you want to do something, so you want to register a basket, the system says you must have a customer first. Okay, that's good, because I don't want to have baskets without customers. And when you put a product in a basket, when you make a basket item, the basket item will say, I need to know what product I'm referring to, because without product, I cannot exist. Okay, and I have to know in what basket I am. Yeah, that's good. But on the other hand, it constrains your business processes. And sometimes, because of agility and because we want to be able to adapt swiftly to new ways of working, it could be an option to make all associations 0 to many. everything is optional and many, no constraints, no maximum one, no minimum one, nothing. And then everything is allowed. But then you have to make sure you work in a clean way.
Mm. Yeah,
So
you have to move the constraints elsewhere, right? In the sense of you have to move to the people.
Move them up to the business process layer.
Exactly.
And then you make sure, for example, you can say, I can assign any person as a teacher to a course, and you have to check once in a while if in the meantime those people have received a contract.
Okay, so there is a question here about ontology-driven conceptual modeling. So if in your opinion, ontology-driven conceptual modeling, for example, OntoUML, could improve business process modeling, what are the main research challenges, open issues in that context?
Oh, I think for me, I think it's really interesting, but I would see it even more from a data modeling perspective than from a business process modeling perspective. I think we still have a lot of work to do on reflecting on what type of objects do exist and how we want to register them and categorize them. I think this could help the creation of models a lot, because too often we start from scratch and we have a very, say, limited view on a number of concepts that we try to include in our models. So for me, it would really be good if our students would be trained in ontological reasoning. I say that because they are not clear about the concepts that they are using. So for example, in the case that I gave, they were talking about ticket types and categories. And then I asked them, what's the difference? Can you define it? What is the concept behind it? They have no clue. They are just taking data elements, putting them together and say, okay, this is a concept. But that's not really a fundamentally good way of thinking about modeling. So I think it would be really useful to have a more ontological grounding of our modeling, even for our junior modelers. For me, that's really important.
I couldn't agree more. Conceptual data modeling and BPM are two faces of the same coin, or if conceptual data modeling encompasses process and event entities as well as their relationships, can we consider BPM as a part of conceptual data modeling?
For me, they are not entirely two faces of the same coin to a certain extent. I would say that a playground and data modeling, those are two faces of the same coin. But then your process modeling can further constrain what you want to do. So, and it adds also notions of actors, for example, what you want to automate, what you want to do manually, and so on. So it's not, it does more. But for me, the defining the playground and the data modeling, those are two faces of the same coin. You cannot do one without the other. And then the process modeling for me further constrains that. I explain it to my students by telling them, when you do requirements engineering, it's way easier to talk to people about their work. So you start with asking them, how do you work? What is your task? What information are you working with? What rules are you observing? And so on. And then from that, you capture the concepts they are working with. And then you try to organize those concepts first until you have a robust and solid domain model that defines also a playground. And then you use that to redefine their business processes. So I start from business processes, go down to the fundamental domain modeling, and then go back to the business process, and then iterate, of course.
So the next question, I'll identify the person in this case, because this is Oscar, and so we can make a connection between the two talks, right? So Oscar says, thanks a lot, Monique, for this interesting talk. I like very much how you provide a holistic conceptual modeling perspective for data and process. What about including interaction in this unified conceptual modeling perspective? Should the right interaction model complement a sound data plus process model? Could the correct interaction patterns also be inferred from data and process conceptual modeling patterns?
It depends on how you define interaction. So in Merode, we do have, of course, interaction because it is already defined by means of the object event table. And what we do there is that we say that when an event happens, there are possibly several objects that might react to that event. And at a level of conceptual modeling, I don't want to say how this reaction is sequenced. So for me, I just want to define, I have this thing that happens in the real world, and this and this and this and this object will react or will verify, because the event in the role is a request to register something that happens in the real world. But think of the engineering aspects of Michael Jackson. We can also engineer that certain things should not happen. So for example, we have a person in a library, person wants to walk out of the library with a book. We could say, we don't want you to borrow a book because you already lost 10 of them. So that's enough. Okay, so the interaction then for me, the loan happens, or the person tries to pass the gate, so that's the event, and then several domain objects will react. The loan will say, okay, I will create myself. The book will say, okay, I'll put myself off shelf, and the member object will say, hey, wait a minute, I have a constraint here, I have to refuse. I cannot, because I have been blocked. I'm on the blacklist. So from my perspective, not allowed. Then, of course, what happens, so it's just a table with a row, borrow, and then say just markings like member, verification needed, book, verification needed, and update needed, loan, no verification, creation. So that would be the object event table. And then, of course, we have to implement this interaction with a pattern, and there different patterns are possible. Those we put in the transformation, how we transform the model to the code. So that would be the interaction at the level of the domain model. And that is also what is formalized by this algebra of Hoare. Communicating sequential processes is a specific process algebra in the sense that it allows for this multi-party interaction, not the binary interaction. UML is more, I send a message and there's an answer that comes back. So that would be the Milner process algebra, for example. And what you need to do is you need to define per event a collaboration pattern, or you can use one pattern for all events. I have a lot of material about that. And that's then, for me, it's part of the transformation. If you talk about interaction at the business process level, that's a different matter. I think there we talk about workflow patterns. I never really studied the interaction between workflow patterns and what this could mean in terms of data modeling. That's something I have not really ever considered so far. Yeah.
There is one question here that several people joined to ask the same question. So thanks for the brilliant presentation. My question is of a pedagogical nature. What will be the best way you reckon to introduce conceptual modeling to first-year students? And what is your experience across different student levels?
I teach UML class diagramming to my economic students, well, business students who have not chosen an information systems major. And the way I introduce it to them is, in particular, using this analogy of the world and the machine, and by referring to the fact that they are using computer systems to know something about the real world. And I think the web shop or buying things is like the most obvious example that you can give to them. Another example that I use, and that is also very relevant to them, is that Leuven automation of systems has evolved over time. When I started as a professor, I would see the students in my class, they would pass an exam, and then when I have finished corrected the exam, I would take this paper sheet, and I would write down the marks. And then if a student was missing on that sheet, I would go to the student office and say, hey, John Doe made an exam. He's not on the list. Can I give you the mark? And they say, oh, yes, probably it's a mistake. Okay, and they enter John Doe in the system, gets the mark, done. Today, a student has to register at the start of the academic year, the individual study program. If a student, it's a contract between the student and the university. If the student does not register my course as part of the contract, even if the student has been there every single class, has participated perfectly, has made a perfect exam, there's no way I can have the student obtain the grade. The computer is dominating the real world. And before that, the world was dominating the computer. If something happened in the real world and it was not registered properly in the computer, we assumed that the computer was wrong. But today, we assume that the computer is right and the real world is wrong. So I motivate my students that they need to reflect at an abstract level about how we organize our information systems. And that's typically convincing for them.
See, that's indeed a very interesting topic. You know, how institutional facts these days are grounded in information facts, right?
Yeah, and I think for me, it motivates them to understand it. And especially for business students, if you make this constant link to the business processes and you constantly illustrate how this impacts the business processes, and I think you want to have a very fancy web shop and you want to have something smart, etc. If it's not designed well, it's not gonna work. Another very, it's also from Michael Jackson, by the way, is this, the boat story, where he has this kind of boat story where a person comes to the consultant to ask to create a little system for registering boat rentals and getting every day the duration, the average duration of a trip. And then later on, the person comes and says, now I want the maximum duration. And initially, in the way the problem has been solved the first time, there was no conceptual model of what the business is about. And the result is that when the second iteration is started, they have to remake the software from scratch because the software is not adaptable. And it's only if you put a domain model as part of the solution that the software becomes adaptable. And I think it's through those little stories that you can convince students of the importance of fundamentally good design of software.
Very good.
Software modeling.
So
yeah.
The last question. Thanks a lot, Monique. In your example of order and delivery, there was no relation between order and delivery. In my view, even though from a purely structural perspective, having reified orders and deliveries as business objects, there must be an order for there to be a delivery. Otherwise, you don't even know what to deliver to whom, etc.
Yeah.
So do you think this kind of constraint belongs to the conceptual data model, or it should only be addressed in a process model?
It's in the data model, and let me go back to that data model and I will show you where it is. I don't know if my screen is still shared.
It's still shared, yes.
Okay, so let's go to, oops, where is it? We're almost there. Okay, whoops, let me take it here. So what you have is that the delivery is a box. In order for the delivery to contain an item, so a box can contain several items. Each item refers to exactly one order line. So there's no way you can fill the box unless you have ordered something. So there is a relationship not between, say, the box in its entirety with an order in its entirety, but with the items in the box, they are related to ordered items.
So the existential dependency in this case would be from delivery to delivered item, because then you can appeal to transitivity of existential dependence, right? But if it's on the other way around,
the delivery line here is existence dependent of the order line and thus of the order and thus of the customer.
But also dependent on
the
delivery.
Depending on the delivery. But the delivery is not existence dependent of the order. So it means indeed in this case you could create a box without having any order.
Exactly.
But that's a choice I made because in the case that I'm describing here, I'm describing the process of ordering office furniture. And I want the customer to be able to order tables, chairs, blackboards, beamers, whatever. And the customer may place several orders. and I want to be able to group those orders in a single delivery. And therefore, I can fill a truck, and the truck contains items, and those items come from different orders. So they can contain, say, 10 tables from the table order, and 20 chairs from the chairs order, and 2 beamers from the beamer order. And that's why it's modeled this way. It also allows me to ship to another person than the one who placed the order. Because if I make it directly, so I change this arrow here, can I pointer option, let me have a pen. So suppose that I remove this one here, and I instead make it like this, and I say I have 1, and then I have 0 too many here. Then of course my delivery belongs to an order that belongs to a customer. Whereas now my delivery belongs to a person and the order belongs to a person. Of course, the person, and that's then the business process, the person placing the order will fill in the address to whom it has been delivered and will fill in the address of the person to send the invoice to, which is actually how it works at our university. You can place an order and ask it to be delivered in some other department and send the invoice to yet another department. That's something we handle then at the business process. That's why I say the business process layer is a playground. I can do a lot of wrong things with this model because it gives me a lot of freedom. But the business process layer can then constrain that to working right. But it gives me agility, flexibility. So it's a more flexible domain model.
Very good. We still have questions, but I think unfortunately we have to wrap up. Thanks a lot, Monique. It's very generous of you to come here to give this talk, this great talk, and answer all these questions. Thanks a lot.
Sure, it was my pleasure.
Next week, so thanks a lot to everyone attending this session of EROSS. It's a very, very high level attendance with really great questions. I will make all the questions available to Monique afterwards. And next week, we're going to have another great talk, and this is by Gilberto Câmara. Gilberto is, he used to be the head of the National Institute of Space Research in Brazil, and responsible for all the systems that monitor the Amazon forest. So he has great stories on how ontology and the proper data management help to interpret, for example, the results of image processing and so on. Now Gilberto is the Secretariat Director of the Group of Earth Observations in Switzerland. And this is a group, an international organization with more than 100 governments involved. And he will talk about ontological issues in big Earth observation data analysis. So this will certainly be great. So I invite you all to come next week. Next Wednesday, 4 p.m. Central European summertime. We'll keep meeting every Wednesday until the last week of October. Monique, thank you very much again. It was great having you here. And thanks to all of you. And until then, stay safe.
I would say thank you for organizing it.
Our pleasure. Bye.